Hello everyone and welcome to another homework help video with Mr. Parsons. So on this video we're going to be doing graphing quadratic functions, lesson 9.1 part 2. So we previously made a video about part 1. It had 8 questions. Here we're going to do part 2 which has 7 questions. The questions, there's a little bit of new stuff here and a little bit of problems just like part 1 but that are harder because they have more going on. So if you're watching this fresh out of watching part 1, that will probably be helpful and make a little bit of sense to you. If not, I'll try and do my best to help you understand what's going on these questions. So follow along, and here we go. So question 1 says graph the parabola. So it says to graph the parabola, imagine being able to say words, plot the vertex and 4 additional points, 2 on each side. Now, if you're doing this with no calculators or help devices, you got your work cut out for you. I'm going to be honest. So I'm going to show you that on this problem, the full steps here. Okay. So step 1 is you need to identify the vertex. So the vertex can be found by taking the equation and finding the axis of symmetry. So let's start with that. Axis of symmetry. X equals, that's the axis of symmetry. X equals, and it's always negative b over 2a, which means you take the opposite of the b value and put it over twice the a value. In this case, the a value, b value, and c value are written out like this. So in our problem, the opposite of the b value, well, the b value here is 2, so the opposite of that would be negative 2. And then twice the a value. Well, there's no number in front of this, but it's technically an invisible 1. So 2 times 1, I'll write it out and be all specific about it. So you get negative 2 over 2, and negative 2 over 2 equals negative 1. Okay, what does that mean? Well, that means the vertex is at negative 1 comma something. So it's work here, okay? So you first find the axis of symmetry. That gives you the x value that you want in your vertex. Okay, but how do you get the y value that you want in your vertex? Well, you got to go back and you got to plug it in. So I'm going to write y equals negative 1 squared plus 2 times negative 1 minus 2. And then you get your calculator out and you get 1 minus 2, which equals negative 3, which means the vertex is at 1, negative 3. Yes, that was a lot of steps. I'm sorry. So first we find the x value, which is on the axis of symmetry. Then we plug it in to find the y value. And those things go into, here, let me draw some lines here. And cha. So if I'm graphing, I'm going to graph a point at negative 1, negative 3. Okay. But wait, I need 2 points on each side of the vertex. Okay, so here's the deal. The x value where the vertex was negative 1, so I need to plug in 2 x values that are less than negative 1 and 2 x values that are more than negative 1. So that's going to require me to do a little bit of a table here. So I'm going to delete this stuff on my paint here. So I'm going to make a table like I did on the part 1. So we have our x values we're plugging in, the formula which we're plugging it into, and the y value output. So I'm going to do this. I'm going to put this kind of in the middle. I know that negative 1, I guess I'll write it out again. Sorry, I didn't mean to erase all that, blah, blah, blah. And that made negative 3. Whatever, we're skipping a little bit there. Now here's the deal. You wouldn't know just to start at negative 1. That's why I had to go do that axis of symmetry and the vertex and all that stuff. So I needed to do all that just so I could confirm this was the central important point. Okay, I need 2 numbers less than that, and it makes sense to just do the next 2 things below negative 1 that are whole numbers, and then the next 2 things that are bigger than negative 1 as whole numbers. So now we have to go through the process of plugging in negative 3 for each of these, and plug in negative 2 for each of these. Notice I'm putting parentheses around it every time I'm plugging it in. That is super important because if you're using a calculator in any capacity, when you plug in negative numbers and square it, if you don't put parentheses around it, you'll get wrong outputs. So it's very important that you be thorough and use parentheses. I mean, typing a parenthesis in the calculator is, in my opinion, very light work. So it shouldn't be, too bad for you. Put that equals negative 3. Okay, now I would calculator all this as I said, so but I'll explain the numbers as we go. So we get 9 minus 6 minus 2, so this should equal 1. We get 4 minus 4, which is 0, minus 2, which is negative 2. And we get 0 plus 0 minus 2, which is negative 2. And we get 1 plus 3, which is 4. Wait, no, 1 plus 2, which is 3, and minus 2, which is 1. You'll notice the symmetry of the outputs, right? It goes 1, 1, negative 2, negative 3, negative 2, 1. That's that should happen. Like if you can find the first two outputs based on the two lower things you put, as long as you scaled the bigger numbers in the same pattern, you should get the same two outputs for the bigger numbers, if that makes some kind of sense. Like if I get 1 and negative 2 for these first two things I did, I should get 1 and negative 2 for the other things. If that doesn't make sense to you, it's fine. Just keep plugging them in. It's totally fine. All right, so there's my points. Whew, that was a process, wasn't it? So we got negative 3, 1, negative 2, negative 2. We got 0, negative 2, and 1, 1. If for some reason your parabola doesn't look great, like let me just do something wrong on purpose. If that happens to you, there's a very good chance you typed in something incorrectly. In that case, I intentionally put the point 1 over. So just make sure you review your points carefully. If it makes a parabola, you're probably doing something right. If it doesn't make a parabola, well, something's probably up with it, you know? Now, if that felt like a long process to you, it is a long process to do by hand. And you'll notice I didn't want to touch a graphing calculator or anything. It was very possible. It just takes a long time. I had to plug in and find the vertex. I had to plug in and find the axis of symmetry, then use that to make the vertex. Then from the vertex, pick two bigger and smaller x values, and then use those to plug into the formula to make out the 5 points. And that's how you can graph the equation. Whew, that's a lot of work, right? All right. Hey, look at this fun stuff from the previous problem. Previous homework. So yes, there's more of this here. It's good to practice this. So let's keep looking at it because on the last graph, we could have analyzed what the vertex was and the axis of symmetry. Actually, we did kind of, but we didn't talk about the intercepts and if it's up or down or whatever. So it's good to see more of that on a different problem. So on this problem, I'm gonna use visual here. So it's over 2, up 1. That's where the vertex appears to be. Again, starting with the vertex is a good idea because right after you do the vertex, you can say, oh, the axis of symmetry is x equals 2. Notice this is kind of how we did the last problem, but we did it in reverse. First, we figured the axis of symmetry. Then we used that to find the vertex. The problem was it was all in equation form, so we had to like plug in stuff and work it out. This one's much more convenient because it's all graphed and we can just look at it immediately, right? Parabola, open upward or downward? Downward. Man, every time I've done these, they've always been downward for me. The x-intercepts, we have 2 at 1 and 3. So I'll put 1 comma 3. Again, don't put, well, if you watch the previous video, don't put parentheses around this. You're not making an ordered pair. You're saying the graph crosses the x-axis at 1 when x equals 1 and when x equals 3. So that's all you have to put. The y-intercepts, well, there's one y-intercept. It's negative 4. As I said in the last help video, there should only be one y-intercept. The x-intercepts can vary. There can be 0, 1, or 2. In my case, in this one, 2. So be on the lookout for the right stuff there, okay? Uh-oh. What'd I do? Uh-oh, can I not count or something? Sorry, I have a hair in my eye. We'll blame it on that, obviously. X-intercepts, 1 and 3. Y-intercepts, negative 4. Oh, I just can't. We're going to blame that on old man eyes, even though I'm not that old of a man. Sorry, it's not negative 4. It's crossing at negative 3. I just was not being careful with my looking. Well, perfect streak's over. That's it. Forget about it. All right, so yeah, be careful. I guess if you make a little boo-boo like me, just to double check. Maybe because sometimes it looks like it's crossing lower than it is. If it looks small on your screen, it looks small on my screen too. Probably because I have it all expanded and stuff. I could zoom in, but forget it. All right, we're gonna graph again. Now, if you're sitting there going, oh my gosh, is he gonna plug in negative b over 2a, yada yada yada, blah blah blah. partially. I'm gonna start it, and then I'm gonna show you something alternative. So if you were told to find the vertex and axis of symmetry first, the axis of symmetry is negative b over 2a. So in this problem, the opposite of the b value is negative 20, because 20 is the middle value there. And 2a is 2 times 2, and that gives me negative 20 over 4, which gives me negative 5. So the axis of symmetry is x equals negative 5. And therefore the vertex is at negative 5 comma whatever you get when you plug in negative 5, right? Should I plug in negative 5 real quick? Hold on. Crunch some numbers here. 50, 104. Okay, it's 5 comma 4. All right. I don't do that in your head by just doing that to make a point here. That's what you would normally have to do, right? Like you'd have to find the axis of symmetry, say negative 5, plug it in to actually find out what the y value is, which is 4, and then you'd have to plug in two numbers smaller than negative 5 and two numbers bigger than negative 5. We're gonna save some steps here, okay? And you're gonna say to yourself, dang. Also, you're also gonna say to yourself, Mr. P, you deleted your answer. Come on, man, you should have graphed that. No, it's okay. So here's what you do. Y equals 2x squared plus 20x plus 54, and it's graphed. Now, going to be upset with me here at this point. You're going to say, okay, okay, now what? Oh, look, negative 5, 4. You graph and it's right there. You didn't even need to plug anything in. So there you go. I encourage you, if you have access to a device, to do it this way. I mean, this is helpful, obviously, right? And even if you're sitting there going, oh my gosh, no, that's cheating or whatever, I can assure you that when I went to high school in the early 2000s, we had TI-83 graphing calculators, and we were allowed to type this in and use the calculator to find the vertex. Now, the calculators back then did not immediately tell you the vertex, but they had some features that you could click through. Thankfully for us, we have access to Desmos.com, and it's totally usable or whatever. You type it in, and there's a vertex, right? Now, the problem is this. I need 2 points to the left and the right. So how do I get those? Right? And as I said on the previous video, you can drag it and try and find whole numbers. Like, you really do not want to be putting decimals in. You really need some whole numbers, but how far do you have to go to find? Wait, I think I saw one. It's a hassle, right? So how do you do it? Well, as I had mentioned before, hit the gear, hit the gear, and then hit the button that says table, and boom, you get a table. Now, I said this last time too. The table spits out some values, right? But these values, 22, 36, 50, those are way too big to be graphed on Desmos. The reason why is because, on Alex, sorry. It's like, these are my two kids, and I'm going to call them each other's name, just so you guys know. All right, so -2, -1, 0, 1, and 2 are always what Desmos spits out as like the 5 points for whenever you make a table. Those are not the 5 points you want, necessarily. It worked out good for us on part 1 because the problems were basic. Like, they didn't have A, B, and C values. It just had A values, or maybe A and C. The B value really messes things up. So how do we make it so that it shows the vertex and then 2 points to each side? So here's what I'd recommend you do. After you've converted it to a table, delete the inputs of the table. I know, it's mad at me now. But what you're going to do is now you're going to type in what you saw. We saw a vertex at -5, right? Put that on there. Now, write two numbers bigger than -5 and two numbers less. I'll start with the less. Let's go 5, -6, -7, and then let's do bigger, -4, -3. Yes, that's all wacky and out of order, but look, it makes the 5 points we want. So now use those to plot. So we got -6 up 6. We've got -7 up 12. We've got -4 up 6. And -3 up 12. Plotted. Now, for your knowledge, let me run you by that again, just so we're all aware. So what my process would be for solving this problem is, step 1, I'd type it into Desmos, and I would observe the vertex. It's very important that you make sure you look at that before you do the next step. I need to look at it and say, oh, it's -5, 4. Okay, keep that in your head. Write it down if you have to. Then convert to a table. The table doesn't have the correct points on it, so what I'm going to do is I'm going to delete them. And I'm going to put that -5, 4 that I was remembering in my head, or at least the -5. It'll spit out 4 for me automatically. And then from there, I need to pick two smaller numbers, -6 and -7, two bigger numbers, -4 and -3. When I say bigger and smaller, I mean comparing to the vertex value, -5. Okay, you can pick anything. Like I could pick 0, right? But it'll give me 0.54. That's not going to fit on the graph. So it probably would be helpful for you, for at least Alex at least, to only put the nearest two numbers above and below the vertex value, okay? I think we're going to get to see one more of those. I mean, I hope we get to see one more of those, and I'll go through the whole process again. But before we do that, hey, another one of these. So let's do what I have been doing. Let's start with the vertex. That's my last question here, but first one I'm going to look at. So it looks like it's left 2 and down 4. So that's -2, 4. And therefore, the equation of the axis of symmetry is x equals -2. Again, it's always x equals, and then whatever the x value of the vertex is. Okay, is it open upward or downward? For once, I get one that's upward. Yay! And then we have intercepts. So we have two x-intercepts, -6 and 2. -6, 2. And the y-intercept here is -3. This time I was careful, right? -3. Okay, I'm careful this time. Check. I think I just like messing it up. Oh, sorry. I wasn't careful on the vertex. It's not -2, 4. It's -2, -4. Whoopsies. I think I just like messing up at least one of the pieces here. On the plus side, your homework will be just like mine, and if you make a little boo-boo, you can just try that one again, obviously. All right. Unfortunately, there isn't another problem in which we're going to do the graphing. I think I'll do one more of those at the end of the video just to give you an extra chance to kind of do it. So if you are stuck on that, make sure you watch the end of the video. But for now, we'll do 5, 6, and 7. I know 5, 6, and 7 are the same three problems because, hey, I make the homeworks and I know what kind of questions they have. So this one says, does it have a maximum or minimum? What is the function's maximum or minimum? Where does the maximum or minimum value occur? This is a little bit out of order. I would actually think it'd be better to say where does the maximum or minimum value occur, then what is the maximum or minimum value. I'm going to show you how to do this one by hand, and then I will show you how to do them maybe not so by hand. Well, by typing by hand. Okay, so first let me write the problem down. We got g of x, -3x squared, -24x minus 49. Okay, so question 1, is it maximum or minimum? This is a very simple to answer question, and it all depends on what the sign of this is. Notice this is -3. That is a maximum. I know you're probably like, wait, no, negative sounds like minimum. No, it works the other way around. The reason why is because without graphing this, I can tell you because there's a negative number in front of the whole thing, the whole graph looks like this. It's upside down. This is the upside down version of a parabola, of course. And what does that have? It has a point at the top known as the maximum. So that's why we're going to call it a maximum, not a minimum. So simple as that. Okay, the next step is I'm going to skip to part 3. Where does the maximum or minimum value occur? See how it says x equals? Isn't that kind of like the axis of symmetry, right? Axis of symmetry is when x equals some stuff. So if you're finding the maximum or minimum value occurrence, that's the same as finding the axis of symmetry. So in my problem, the opposite of b, which is positive 24, over twice the a value, so 2 times -3, and I get 24 over -6, which divides to make -4. Hey, that's where the maximum or minimum value will occur. So I know that when you plug in -4 into this equation, that will be the point in time that you'll get a maximum or minimum on the graph. Okay, what is that maximum or minimum? Well, that's the question. You got to plug it in, right? So I got to actually plug in. So g of -4 equals -3 times -4 squared. 24 -4 minus 49. Okay, this is calculator work right here. I'll show you some intermediate steps, I guess. So -3 times 4 squared will make -48. -24 times 4 is 96 minus 49. I believe this will end up equaling -1, which means when you plug in -4, you get out -1. So what's the value? -1. I'm scared. Like, doing all this by hand makes me nervous. Oh, answer all the questions. Sorry, I didn't click. Maximum. Okay. Huzzah! I got it right. Okay, so let's review that. Let's review those steps. So step 1. Maximum or minimum depends on what the a value is. In my case, it's negative, which means the graph is upside down, which means it has a maximum. If it had been a positive number, I would have said a minimum, which is the normal setup, I guess. Okay. I then skipped to box 3, which said, where does it occur? That's the same thing as saying, what's the axis of symmetry, or the x value of the vertex. So I plugged in negative b over 2a, I got negative 4. Okay, then what is the maximum or minimum value? That was me typing it in, and I got out negative 1 there. Voila. It's a process, but if you have no calculator, that's how you want to do it. Now, what do you do if you have a calculator? Oh my gosh, cheesy. All right, I'm going to type this in. You don't have to type g of x, by the way. I'm just doing it because I feel like it. Hey, look at that, it graphs. Okay, I really don't care what the graph, shape is or whatever. I guess it's helpful, I guess. But the points, the intercepts, and the vertex and all that stuff, not all important. The vertex is super helpful, and I'll tell you why right now. So number 1, does this have a minimum or maximum? Well, if you look at the graph, there's a bottom point. That is called a minimum. Also, if you look at the equation, it had a positive number up front, which follows along with what I said before. A positive number means a minimum. Okay, the next step is, where does this maximum or minimum occur? This was the third box on the previous problem, but here it's the second box. They do switch the order up, so be aware of that. Where does it occur? It's the x value of the vertex, too. Simple. What is the maximum or minimum value? That's the y value of the vertex, 3. Now, if you just watch the last problem, and now you watch this, you're thinking to yourself, well, why am I going to do all that work? Yeah, you're right, I guess. Okay, so yeah, if you want to graph it, this is the quick way. You can look at the graph and determine maximum or minimum based on the shape, right? If it's upside down, that's a maximum. If it's normal way like this is a minimum. Where does it occur? When x equals the x value of the vertex. What is that value? The y value of the vertex. Strangely enough, it doesn't say y equals, but whatever, you don't need to put y equals. Let's do one more, and I will show you the cheese. 2x squared minus 20x. Hey, that's all. Wait, is this like so close to the last problem I feel like I did a second ago? No, it had a negative 3 in front. Okay, whatever. Hey, notice I didn't type f of x. No big deal. It's okay. Here's my vertex, 5, negative 4. That's going to be important information. Does this have a minimum or maximum? Well, it has a minimum, right? It doesn't go any lower, so that's a minimum. I'm going to skip to box 3. Where does this minimum or maximum occur? When x equals 5. What is the maximum or minimum value? Negative 4, the y value. That's it. That's how you interpret a graph. If you can graph it, finding this information will be way easier than if you can't graph it. And you know what? You have all right in the world, in my opinion, to graph it. So please do. Oh, darn it. How do I do this? I said I would do problem number 3 again. So hold on a second. I'm going to show you one more problem number 3, because problem number 3 was a little spicy. So I want to show you how to do it with the graphing calculator here again. So for those of you who are like, how did he do all that? So I'm gonna do it. I'm gonna try and do it quicker so it doesn't sound as confusing. So y equals negative 3x squared plus 6x plus 4. So I graphed it on Desmos. I look at the vertex. It's 1, 7. I convert this to a table. The table does have some points that are actually pretty good, but it doesn't have everything I want. So what I recommend is, by default, just delete it all. It's fine. Type in 1, because remember, the vertex was at 1, 7. You got to remember that. Then I write 2 smaller numbers, 0 and negative 1, and 2 bigger numbers than 1, 2 and 3. And it gives me all the points I want. Now I'm going to do it. So 1, 7, 0, 4, negative 1, negative 5. Ooh, that's a steep one. 2, 4, 3, negative 5. You notice as you go down, the height of these left and right side dots that sprout out from the vertex, they should be the same height. If you're not making them the same height, then something's iffy. All right, that was me doing part 3 again. By the way, you can use that same method on question 1. Question 1 is just like 3, except for I believe I set it so that it doesn't have an a value, which makes it a little bit easier to graph, but it doesn't really do much. So if you'd like to do these graphings with the graphing calculator, again, you graph the thing, think about what the vertex is, convert it to a table, and then use the vertex and 2 lower and 2 higher points to plot your points on that there. And that's how you can graph using a graphing calculator, I suppose. That's all I got for you then. Can I hit submit assignment? Sure, submit assignment. Yeah, 14%. Woohoo! Hold on, let me go. Yeah. All right, let me revisit everything then from my go through here as is tradition. So number one, I graphed it. I showed you how to do this by hand by making a table, plugging in specific x values and y values. The way I decided which x values to use, though, really depended on what the vertex was. So I had to go through the process of finding the vertex, finding the axis of symmetry, then using that to find the vertex, and then making a table with 5 points that include the vertex in the middle and then 2 higher and 2 lower, and then I was able to plot those 5 points and make the graph. On number 3, I bypassed a lot of that by showing you how to graph it on Desmos and then adjusting the table on Desmos so that you can see the 5 points you want to see, because it doesn't by default show you the 5 points you want to see. Would be a nice feature, but it's okay. They don't have to do that. On problems 2 and 4, we looked at more of these graphs where you analyze the vertex, axis of symmetry, the intercepts, whether it's facing up or down. And, as it would be, I missed one on each one of those each time because I'm a goober. And then on 5, 6, and 7, we found the minimum and maximum of a function. First, we identified if it was a maximum or minimum. And then we found where it occurs, x value-wise, and what it is, the y value. And I showed you how to do this by hand, which isn't too bad. It's kind of like when you graph it, but you get to save a lot of steps of not having to find the extra 4 points. So that's kind of nice. But then I showed you how to find it pretty easy on Desmos. If you just graph the equation, you can look at it and find it pretty easy. All right, so that's that. That's 9.1 part 2. Hopefully this video was very helpful for you. Again, like I said on the last video, if you have questions, please hail your teacher. They will be willing to help you on this. This unfortunately chapter 9 and 10, if we get to chapter 10, are the hardest ones in the book, as they would be the last things in the book. So I can understand if you're struggling with this. So please reach out to somebody and get some help. Or hopefully, if you watch this video, then you got some help. That's all I got to say about that, and I will see you guys on the next video. Goodbye.